My name is Liam McChesney, and I am pursuing a major in aerospace engineering.
Hello, I am Daniel Orthel. I'm an electrical engineering major.
Hello, my name is Thomas Collier, and I'm majoring in aerospace engineering.
Hi, I'm Joe Maki, and I'm an aerospace engineering major.
This project was created with the purpose of drying off wet boots in the winter season in an energy-efficient manner. Our team created a stand for the boots using PVC pipe and an enclosure for the control system made out of laser-cut acrylic. A clue board is used to control the speed of the fan and the temperature of the heater that are used to dry off the boots. When the system is turned on, it compares the humidity of the room to the humidity inside the boots, and then dries them until the values are equivalent.
Our design challenge was to create an autonomous system that could dry off the boots of the user. The challenge was to ensure that the software would control every aspect of the system. Our unique approach to this challenge was to use multiple transistors and separate voltage inputs to allow for a variable output to the fan and heater, which will allow our system to be very efficient as it's not running at maximum output at full time. Here you can see the final software flowchart for our device. When the device is plugged in, it immediately starts reading the temperature and humidity of both the room and the boots. The device then compares the humidity of the boots to the humidity of the room to decide what voltage to set the fan at. If the humidity is close to the desired humidity, the fan will run at a lower voltage, and if it's way off, it'll run at a higher voltage. The device will then perform a similar function with the heater so that the boots are nice and warm when they're finished drying.
Today I'll be talking about the electronics for the project. To start off with, we have a lot of different settings for our fan and the heating pad. To get these different settings, we have our transistor with the flat front and the rounded back. So we use 3 of those, and by turning those on or off, we can get different speeds from the fan and different heats from the heating element. So you can see on this that it is reading the room temperature, room humidity, boot temperature, and boot humidity. So of course using our sensor right here. So if you observe the fan, if I blow on this to increase the humidity, it can get it just from my talking. The fan speed increases.
I'm here to talk to you about how we use the design process to accomplish our goals. This can be seen extremely well on the electrical side of things. Our schematic changed multiple times throughout the process. Each time we incorporated new things we'd learned, and it became a more detailed version of what our final product would look like. As you can see, the first few don't look like schematics at all. In the end, though, we were able to accomplish our desired outcome through the slow evolution of our electronic design. We began using voltage regulators, then moved to transistors in parallel, and finally to transistors in series in order to change the voltage going into the fan and heating.
This is the CAD for the enclosure that rests on top of the PVC and holds the clue in the breadboard. It's a 6x6 by 4 inch box, and the top face swings open, and 2 of the sides have holes on them, and this is what was used to print it out. The PVC base consists of 8 different 2-inch thick pieces, 2 foot long tubes, 3 4-inch long tubes, 2 elbow connectors, 1 T-piece, and 1 connector.
The most important thing that we would change from the project is the speed with which we ordered necessary parts. Parts that were integral to the success of our project did not arrive until a week and a half before the deadline. This made integration stressful and risky. Despite the time crunch, we were able to effectively integrate. However, although everything worked out, had we ordered parts a week earlier, we would have been in a much more comfortable position entering integration.
Another thing that we could have done to change our project would have been planning ahead a bit more with our materials. The metal hinge we got was very stiff, and the metal screws could have damaged the acrylic sides, so we ended up not using it. Our team grew a lot because we started off working on our own parts of the project pretty independently, but as the project went on, we collaborated and talked a lot more.